Hello and welcome to another one of these ADD videos. Today we're going to be looking at the area between two curves illustrated by a few basic examples. So general concept recap, we got to do the top function minus the bottom function. The way you find out which one's the top is you can either graph. Most people don't know all their graphs, so I recommend you set them equal to each other because you're going to usually need to find the intersection points anyway, so might as well do it right away, and then pick a test point in between those intersection points. And whichever one gives you the largest answer, that's the one that's on top and comes first in your integral, okay? If there's more than one region of interest, if there are multiple intersection points, then plug in more than one test point. So find your intersection points, determine which one's on top, plug into the formula, integrate, and plug in bounds. Okay? So let's look at these examples now that we recapped. So the first one we have is this function here. If I were to use a graphing method, I could graph this function pretty quickly, hopefully, seeing as it's a linear function. Each one of these hash marks, I want to say, is 4 units. Okay, it'd be nice if they were equidistant. There we go. And what we would do is we'd plot the y-intercept of 8. So if this is 4, this would be 8, and we'd put a point there. And then the slope is 4, so we would go up 4 and to the right 1. Okay, so there's my graph of my straight line, and you can see it does intersect the x-axis, but nowhere near our range of 0 to 2. We're only interested in this function from here to here. Okay, so there's our region of interest. I'll highlight it in yellow for you. And we need to find the area of that region. So what do? Well, we can, let me show you real quick how you can find the intersection points of the x-axis in that function if you just set them equal to each other. So just algebraically, let's say you forgot how to graph, set them equal to each other. So we know y equals y at their intersection point, so 0 equals 4x minus 8. And then you're going to add the 8 on both sides. And you're going to get 8 equals 4x. And then, ooh, something's fishy. Oh, it was 4x plus 8. Sorry, people. So that should be a plus sign right there. As a result, these both should be minus signs. This is what happens when you make multiple videos back to back to back. But you see how easily you can make a silly mistake and then it'll mess up your problem. So this is a negative 8. And when I divide, I get x equals negative 2. Much better. That looks a lot more like my graph, okay? So it never hurts to do multiple methods. Better to err on the side of caution to err if you're going to err at all. That means it's better to be safe than sorry. So now that we got that and we see that our intersection point with the x-axis is nowhere near that negative 2 or the 0 to 2 region we're looking at, if I pick one, a test point in between those two, and I plug it into here, I get 12 on one side for the 4x plus 8. And then the 0 function is 0. The x-axis is always 0. We're testing to see which one is greater than, or is this one the bigger one? What's going on here? And we find out that indeed, oops, I made those in the same direction. This function here, the 12, is the larger one. So 4x plus 8 comes on top. Now, it might be obvious to you which one's on top because you know how to graph linear functions, but it won't always be that obvious, or you might forget your functions. In this case, all you do from this point is you go from 0 to 2, and you're going to do the 4x plus 8 minus 0, which is not going to affect it, dx. So then you would integrate, and you would get 4x squared over 2 plus 8x, evaluated between 2 and 0. Then the 4 and the 2 cancel, and you get 2x squared plus 8x between 2 and 0. So you're going to get 2 times 4 plus 8 times 2, which equals 8 plus 16, and your area would be 24. All right? And that's basically it for area between two curves. It does get a little bit more interesting if your intersection point with the x-axis lies in between your interval. So here you see how we have a new example problem, two same functions but different intervals. We're going to look at them between -4 to 0. So if this is -2 right here, -4 to 0 definitely encompasses it. And you should be able to see that now we're going to have two regions. We're going to have that region and that region to look at. Okay, so I'm going to just do strictly setting them equal, and when we set them equal, we got -2. So because it's -2 is the equal point, we would have to do two separate integrals, one from -4 to -2 of the function. And which one's on top? Well, if I plug in a -1, or actually a -3 for that value, right? Your test point always has to be in between these two numbers. So if I plug in a -3, I get 4 times -3 is a -12 plus 8 is a -4 for this function. And then 0 is always 0, so that means 0 comes first on this one. So when we do top minus bottom, it's 0 minus 4x plus 8. Okay? And then you would distribute the negative sign and integrate and plug in the bounds just like before. That's the easy part. Most people have problems just setting up the bounds. Okay? Again, it'd be the -2 plugged in first and then the -4. After you integrate, though. This one hasn't been integrated. So when you integrate, you should get this answer that you got, or I got right here. And then you could plug that in to 2x squared plus 8x. So when you integrate, you get 2x squared plus 8x. Now in this case, ooh, I forgot to distribute my minus sign too. I'm making little silly mistakes. This is what happens when you're tired. I worked 13 hours a day before with my students on campus and 12 yesterday, so I'm pretty beat. Finals week is kicking my butt. So in this case, both of these would be negative. The actual integral answer didn't change, it's just the sign of these, because still 4x plus 8 we're integrating, the constant is -1. So then you would plug in the -2 everywhere and subtract the 4. Sorry about that. All right, last example. This one we actually have to set equal to each other. I'm not going to graph it at all. I think the graphing method is not going to work for most of you guys just because you don't remember your graphs. So always, when you set y equal to y, don't divide that x. You'll lose one of the intersection points. Bring it to one side and then factor out what's common. And then you get two things multiplied equal to 0. The law of 0 says you can individually set them equal to 0. And then you get x equals 4. So those are your endpoints. Pick a number in between, plug them into both y's. So y equals x squared. I'm going to pick 1 because it's a nice, easy number to deal with. That gives you a 1. Whereas if I plug into 4x, I get 4 times 1, which is 4. So that just told me that this is the top function, and it comes first. So we would do the integral from 0 to 4, and the 4x minus x squared dx, and then it's the easy part. You integrate, hopefully you remember, 1 plus 1 over 1 plus 1. So you get 4x squared over 2 minus x cubed over 3, and no plus c because these are bounds. You plug in, and here you're going to have a 2x squared minus a x cubed over 3. So when you plug in a 4, you get 2 times 2 squared minus, 4 squared, 4 cubed over 3. And then you get 2 times 16 minus 64 over 3. So then you get 32 minus 64 over 3. So over 1, you can find a common denominator. So times 3 on both of those to get that. So we would have a 96 over 3 minus a 64 over 3. And what is that? 32 over 3 if you do that. And that would be your answer for the area between those two curves, okay? So always try to find out which one's on top first, and then after you find out which one's on top, go to your top minus bottom equation and integrate and plug it in the bounds. Always make sure to check that it doesn't touch the x-axis in between, or check for multiple intersection points, meaning multiple regions, meaning multiple integrals, okay? So I hope I've helped. Let's see. Ooh, something's missing. Sorry, people. I didn't do the second half of this integral, did I? So hopefully some of you are watching this video going, what the hell? Where's the rest of the problem? We have to go from -2 to 0, and the test point there would be 1. And the two functions, if you remember, were the x-axis and 4x plus 8. And you would, if you plug in 1 to 4x plus 8, you get 12. So that's the top function, minus 0 dx. And you would integrate and get an answer. Okay, add this answer for this one from -2 to 4 to this answer. Sorry, this is a rough draft video. I apologize. My puppies broke out and distracted me a little bit. But hopefully you still understand the concept. The only addition I made was the second half of this integral right here. I forgot to add that. All right, these are rough draft videos, so bear with me. I'm trying to do every chemistry, every calculus, and anything else, OChem, biochem. So I'm a little busy. I apologize, but I will rectify it as soon as I can. But in the meantime, check out the more advanced example videos. Practice, 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 and thank you, and have a nice day.